Bright Duty. Every student matters.
Now let us take a few numericals based on the topics that we have studied till now. Let us see. The first question, a constant force acts on an object of mass 5 kilograms for a duration of 2 seconds. Now let us see first of all what exactly is given to us in the question. The mass, which can be represented by small m, is given to be 5 kilogram for a duration of 2 seconds. The time is given to us, time t is 2 seconds. Now it increases the object's velocity from 3 meter per second to 7 meter per second. That means initially the object was moving at 3 meter per second. That means we are provided with the value of initial velocity. Now initial velocity represented by small u is given to us to be 3 meter per second, and this has been increased to the final velocity v, that is given to be 7 meter per second. Find the magnitude of the applied force. The magnitude means the amount of force. So what we need to find is, we require to find the amount of force. Correct? This is the first part of the question. Now in the second part, what he is trying to say is, now if the force was applied for a duration of 5 seconds, what would be the final velocity of the object? That means on increasing the amount of time from 2 seconds, now we will apply the force for 5 seconds. Then the object which was initially moving at 3 meter per second, we need to find out at what speed or velocity that will be moving. So first of all, let us calculate the force. Now we know that F is equal to m into A. This is from Newton's second law of motion. From second law of motion. Now we are provided with the mass. Mass is given to us, but A, acceleration, is not given. So if we relate and observe in the question, we are given with other values which will help us find the acceleration. How we are going to do it? We are given u, we are given v and t. So now I hope it is clear to you that we can calculate A with the formula v minus u upon t. Students, we need to specify always from where does this all formula come, right? So we have to specify in the brackets F is equal to m into A. Why? Because Newton's second law of motion stated it. A is equal to v minus u upon t. This is because of the first equation of motion. So now putting the values first of v, u and t, we will calculate A. V is 7 meter per second minus u is 3 meter per second, and the time given was 2 seconds. So it comes out to be 4 upon 2, which comes out to be 2 meter per second square, right? This is the SI unit of acceleration. I hope you remember. Okay. So now we have got acceleration 2 meter per second square, but the question asked us to find out the force, right? So now the force will be F is equal to m into A. M, the mass value is given to be 5 kilograms. A, we have just calculated 2 meter per second square. The force comes out to be 10. 10 what? Yes, unit. And what is the unit of force? Newtons, right? So Newton, 10 Newton will be the amount of force. Correct? Now this is the solution of the first part. Now in the second part, what he is trying to ask is that if this particular force of 10 Newton that we have just calculated, it was applied for a duration of 5 seconds. Now we know that once again F is equal to m into A. F is equal to m. Rather than writing A, I can write v minus u upon t, or this becomes F multiplied by t is equal to mv minus mu. Now mass, we know exactly what the mass is. Force we have just calculated 10, time now given to us is 5 seconds, mass is 5, V we need to calculate, mass is once again 5 putting its value, and U it was moving with a velocity of 3. So it comes out to be 50 is equal to 5V minus 15, taking 15 on the other side I will get 15 plus 50 is equal to 5V, or 5V is equal to 65. Therefore, V is equal to 65 by 5, which comes out to be 13 meter per second. This will be my answer, that if this 10 Newton force is applied on an object which was moving at an initial velocity of 3 meter per second, and this force is applied for 5 seconds, then its velocity will reach 13 meter per second. Got it? Quite simple, just putting the values. Okay, good. Let us see the next question. Now this question is quite important. These type of questions you normally encounter in your exams. Which would require a greater force? We are asked to compare the two forces. First option is given to us is accelerating a 2 kilogram mass at 5 meter per second square. Right. Let us see what exactly is given to us. The mass is given to be 2 kilograms and the acceleration to be produced is 5 meter per second square, or a 4 kilogram mass at 2 meter per second square. Another case, the mass of another object is given to be 4 kilogram and we need to accelerate it at the rate of 2 meter per second square. So in order to differentiate, let us say that mass of the first object is m1, the acceleration is a1, mass of the second object let it be m2, acceleration a2. Now the force required for producing an acceleration of 5 meter per second square on this object of mass 2 kilogram, let that force be m1, which will be equal to, as per the Newton's second law, m1 into a1, because F is equal to m into a, and let the force required for accelerating this second object with mass 2 kilogram be m2 into a2. Simply we will calculate F1, all the values we already know. So mass is 2 kilogram, acceleration is 5, this comes out to be 5 into 2, that means 10 Newton. This is the first force, and the second one is mass is 4, acceleration is 2 meter per second square, comes out to be 8 Newton. So the force required to accelerate 2 kilogram mass object at 5 meter per second square will be 10 Newton, whereas the force required for accelerating 4 kilogram mass object at 2 meter per second square requires 8 Newton. So we can very well observe and relate that this is more amount of force which is required. So the force required for accelerating 2 kilogram mass at 2 meter per second square will be greater as compared to the second force. Got it? Next, now let us see, a motor car is moving with a velocity of 108 kilometer per hour. Let us see what exactly is given to us in the question. This motor car is already moving with this velocity, that means it is the initial velocity given to us. This is represented by small u, this is given to be 108 kilometer per hour. We need to convert this unit, which comes out to be 108 multiplied by, written as 1 kilometer divided by 1 hour, right, or 108 multiplied by, we know that in 1 kilometer there are 1000 meters, divided by 3600 seconds, because in 1 hour there are 3600 seconds. Cancelling it out, what we will get is, we will get 108 multiplied by 10 upon 36, right. Now you all must be aware, I have already mentioned in my previous lectures, that whenever we are going to convert kilometer per hour into meter per second, when we do this thing, it basically indirectly comes out to be 5 by 18, right. This is 5 by 18, simple. If some of you they are not aware, then every time you are going to convert kilometer per hour into meter per second, just we need to multiply with 5 by 18, right? So now it is 108 multiplied by 5 by 18, cancelling it out, we'll get 6, that comes out to be 30 meter per second. So this is the initial velocity. It takes 4 seconds to stop. So now the time is given to us to be 4 seconds and the body stops. This motor car is stopping after the brakes are applied. That means the final velocity of this motor car represented by small v is given to be 0. Calculate the force exerted by the brakes on the motor car if its mass along with the passenger is 1000 kilograms. So mass is also given to us is equal to 1000 kilograms. We need to calculate to find the amount of force required. Now we know that force is equal to m into a. From where? From Newton's second law of motion. This is as per Newton's second law of motion. Now as per it, now F is equal to m into a can be written as v minus u upon t. Why? Because a is equal to v minus u upon t. From where did it come? From first equation of motion, right? So now simply we need to put the values. F is equal to mass given to us in the question is 1000 kilograms multiply by v given to us in the question is 0 because the body stops. Initial velocity we have already calculated 30 meter per second and the time taken was 4 seconds, right? So this comes out to be F is equal to 1000 multiplied by minus 30 upon 4, cancelling it out we will get 250. So force is 7500 Newton and this is coming in minus. Now the force, can it be in minus? It is coming out to be in minus. This minus sign indicates that it is the opposing force. It is in opposition to the direction of the motion of the car, right? So this minus signs, this is not basically a negative force, but the force is in the opposite direction. So this is the amount of force required to stop that particular motor car. Understood? Now let us see the next question. Now this is quite important question. This has come many times in the examination. Please try to relate. It's very simple, but we need to just simply relate what the language of the question is. A force of 5 Newton gives a mass m1. We are not given the actual mass. So the mass of first object is given out to be m1 and when this force is applied, force is of 5 Newton is applied on this particular body or object of mass m1, an acceleration of 10 meter per second square is produced. So the acceleration produced in this particular object, let it be a1, this is 10 meter per second square, right? Now what he is saying is, and this force only, this is assumed, this is not specified because it is run on in the question. Try to relate. I repeat the question once again. A force of 5 Newton gives a mass m1 as acceleration of 10 meter per second square and a mass m2. That means the amount of force remains the same and now the mass of second object, there is another object whose mass is not given to us, it is given to be m2, not any numeric value, an acceleration of 20 meter per second square. This is the acceleration which is produced by this force in that second object. What acceleration would it give if both the masses were tied together? Try to relate the questions please. let us say an object of mass m1. Let us hypothetically, I am not going for this particular question, just to illustrate an example, that if I take a pen, right, and then I apply a force of 5 Newton and throw that pen, right, it accelerates at 10 meter per second square. Now, if I apply the same force of 5 Newton on a sharpener or an eraser, let us say, right, then the acceleration produced in that sharpener or eraser, which is my second object hypothetically, that is 20 meter per second square. Now the question is asking us that if I combine this pen and this eraser or sharpener, whatever we have taken as a second object, if we bind them together and then we throw this combination of pen and eraser with the same force, now with what acceleration will it move? So first of all, I need to know what exactly is the mass of the first object and the mass of the second object, and we can find it quite conveniently because the information required is given to us in the question. How? We know that force is equal to mass into acceleration in the first case. Similarly, force is equal to mass into acceleration in the second case. F1 or F2 you could have taken, but the amount of force is same, so it may be F also. Force is given to be 5, mass I will keep it like this, I need to calculate, acceleration is 10. So from here I will get m1 is equal to 5 by 10, or I can say m1 is equal to 0.5 kilograms. Similarly, putting the values here, the force is of 5 Newton, m2 I need to calculate, acceleration is 20, so m2 comes out to be 5 upon 20 and m2 it comes out to be what? 0.25 kilograms, right. Now, the value of both the masses I know. If I am combining these two masses, then the total mass of this combination may be given as m is equal to m1 plus m2. So, mass becomes 0.5 kilograms plus 0.25 kilograms. This comes out to be 0.75 kilograms. This is the mass. The force remains the same, 5 Newton. Now I have to calculate the acceleration produced. So I know once again that F is equal to m into A. Keeping m here, I will get F upon m. Force is given to be 5 Newton divided by the total combined mass of both the objects now is 0.75. This is the acceleration, removing the decimal and just multiplying it with 100. What will I get is, I will get, cutting it with 25, I will get 25 for the 25 3 the acceleration comes out to be 20 upon 3, or acceleration comes out to be 6.67 meter per second square. So if I will put together or combine both the masses and by applying the same force of 5 Newton, then I will get an acceleration of 6.67 meter per second square. Got it? Clear? Understood? Now let us see another question. Now we are given a graph, the velocity time graph of a ball of mass 20 grams. What is given to us in the question is, we are given the mass of the ball taken to be m, it is 20 grams. The mass is in grams. So first of all, we will calculate it and convert it in kilograms by dividing it with 1000, which comes out to be 0.02 kilograms. Moving along a straight line on a long table in as given in figure. Now this is the figure, let us try to relate. The initial point from where it all started was 0. On the y axis we have got velocity, on the x axis we have got time. The velocity is in centimeters per second and the time is in second. Now initially the object, the ball, is at 20 centimeter per second. Then it is a straight line which shows a uniform retardation, and the object is, the ball is retarding, and at the end of 10 seconds the velocity is coming out to be 0. So if I try to relate from this graph, I see that the velocity with which this object started as per the graph, that is the initial velocity or small u, is given to be 20 centimeter per second, and the final velocity, that is small v, is given out to be 0, and the time taken by this ball to decrease its velocity from 20 centimeter per second to 0 is 10 seconds. How much force does the table exert on the ball? We need to calculate the force required. How? We know, as per Newton's second law of motion, F is equal to m into A. Now replacing A with V minus U upon T based on Newton's based on first equation of motion. Now putting the values, the mass. So F is equal to m into V minus U upon T, because as per first equation of motion, acceleration is equal to V minus U upon T. Now putting the values, the mass is given out to be 0.02 kilograms multiplied by the final velocity is given to be 0 minus the initial velocity is 20 centimeter per second. Now 20 centimeter per second, we need to take it into meters. So if we need to convert it into meters, we will once again divide it with 100 divided by the time taken is 10 seconds. So this comes out to be 0.02 multiplied by minus 20 upon 1000, this 100 and this 10. So this comes out to be 0.0004 what? Newton. So this will be the amount of force required to stop this particular object. Got it? So these are a few numericals based on Newton's second law of motion. I hope you have understood it. Please try to practice them. Alright.